Welcome back to Chapter 0. This time we're going to be looking at Section 2, which is about functions and graphs. Like last section and most of this chapter, this is stuff that you should already know how to do pretty well. In this one, there's a bit of vocab we're going to look at. Sometimes the words get a little bit mixed up, and we're going to look at different types of functions. But for the most part, I should be telling you stuff that you already know. So let's get started. Our learning targets for today. You can write a formula for a function described in words and use the formula to find a value. We can find the domain and range of functions and graph the functions. We can classify functions as even, odd, or neither. That would be some of the vocab that people tend to forget. We can graph piecewise functions or find a formula for piecewise functions from a graph. We have dealt with piecewise functions a few times in the past, and generally speaking, people get them, but it's still the beginning of the year, so we'll take a look at that. And use the vertical line test to identify functions. That would be to identify if it is a function or not. So, functions. What is a function? A function is a relationship between two variables that every input goes to exactly one output. Generally speaking, the input is x, the output is y. So when x equals 2, there is exactly one y value that gets associated with that. That does not always work the other way around. There could be two values, like in y equals x squared. That's a function. Every x value gives us a specific y value. However, if we look at the y value of 4, that could be either a 2 or a negative 2. That's okay. And so that's the idea of a function. We test to see if it's a function. Look at a graph by the vertical line test. We just draw a bunch of vertical lines. If no vertical line will touch the function more than one time, then it's a function. If it touches it more than one time, it's not a function. It's still a relation, but it's just not a function. So like a circle would not be a function. Other good vocab words. The domain. The domain is the restrictions on the input. So generally speaking, what can x be? We'll talk a little bit more about that in just a minute. The range would be the output. What could y be? Function notation. Instead of saying y equals x squared, we use f of x equals x squared. It's a function of x. That's a very generic one. If we had a second one, it's usually g of x, because g comes next in the alphabet, and then h of x for the third one. That gives our functions names so that we can talk about them and differentiate them when we're dealing with more than one thing. Also, function notation is nice because we don't necessarily have to use f of x. We could have h of t. Maybe we kicked a ball and we're looking at the height of the ball at time t. So we can label them so that they make sense. Another nice thing about function notation is something like f of 3 equals 5. That means when x equals 3, y equals 5. It's basically an ordered pair, 3, 5. So lots of reasons why we like using function notation. The independent variable is the input. It's what the domain describes. It's generally the x or whatever would be in that x, the horizontal axis. And then the dependent variable is the one that depends on the independent variable. That would be the output, which is f of x, or y, or the height. And so we have those. So more on domains. Finding domains. Generally speaking, for a function, dealing with x, the domain is all real numbers, except we can't divide by 0. So if you have x in the denominator, that might limit your domain. We can't have the square root of a negative number. So if you have a square root with an x in it, that might limit your domain. We can't have a log of 0 or a negative number. So if you have a log of 0, if you have a log with an x in it, that will probably limit your domain. And then some trig. Basically all the trig except for tangent and cotangent. I'm sorry, sine and cosine. I don't know where tangent and cotangent, I was writing trig and the t was there. All of them except for sine and cosine have vertical asymptotes because they're fractions which end up with a sine or cosine in the denominator, and that would get you a 0 in the denominator. So those have spots where the domain is not defined. So that's generally the rules, but there's also times for like a circle where it just can't get bigger than a certain value. So there are special cases where you have to look at it. For example, if we had the circle x squared plus y squared equals 16, that would be a circle centered at 0, 0, and the radius of 4. So x is not going to get beyond 4 or negative 4. It's going to be in the middle there. And so it's just something you have to be aware of. If we look at this, I mean, we can kind of cover up the y squared because that's just going to make things bigger. So if that was 0, which is the smallest that y squared could be, we have x squared equals 16, which would be 4 or negative 4, and we just take the stuff in the middle. So that's just something you have to pay attention for, things like that. There's not always a formula, special case that goes along with it. One thing that can help is by graphing it, viewing and interpreting graphs. Sometimes it's nice to have the domain before graphing, but graphing can also help find the domain. We've been graphing for a number of years now. We've graphed with technology, like your graphing calculators. I'll show you how to use Desmos to graph as well, because some of you might not have graphing calculators at home, and Desmos also has some extra features that the graphing calculators don't. The graphing calculators have some features that I don't think Desmos has as well. So it's not like one's better than the other, but one may be more convenient than the other, especially at the moment. So I will be showing you how to do that. It's pretty easy. If you want to know, you just go to desmos.com and click the graphing calculator button, and it takes you right there. But viewing and interpreting graphs. So when you're looking at graphs, there's a great thing. I hadn't seen this until I saw this book. They really laid it out quite nicely. It's the graph viewing skills. Number 1, recognize that a graph is reasonable. Like, does that even make sense for that graph? That comes a lot with just experience, but there are certain things that you should see. Like if you graphed like a quadratic, you should expect to see a parabola. If you saw something different, it's like, oh, wait a second, that's not reasonable at all. Maybe you saw a line. Like, well, maybe the parabola is just really big and you're just looking at a little piece of it that looks straight from your viewing window. Second, see all the important characteristics of the graph. If you're looking at a parabola, you need to see the vertex, possibly even the intercepts. You want to see some asymptotes. I mean, there are things on graphs that are important to see that really define the graph. So you need to be able to see that. And again, these are skills. They're built from practice and stuff. Interpret those characteristics. What do they mean? Like, what does it mean for the equation? What does it mean for the situation? If this is a word problem, what is that? And also see all the important characteristics of the graph. So the viewing window could be too small. It could also be too big. if you're super zoomed out and all the details are really close, then you're not going to see the stuff that you need to see, even though it might actually technically be in your viewing window, just not going to see it. And then finally, recognize grapher failure. Sometimes your graphing utility, whether it's a calculator or computer program, kind of falls flat on its face. Usually that has to do with either the pixels or just the way that the graph works. For example, if we were to graph this x squared plus y squared equals 16 on the graphing calculator, it would give us something that looks kind of like that. So it gives us like half of it. It gives us the positive half because it graphs a function. So, all right, we can put it into two. There are ways to make it graph both sides. So we'll put in the positive and we'll put in the negative. It's still missing these pieces because the way that the graphing calculator works is it's just plugging in values of x, and it gets to like 3.95, and the next value it wants to plug in is 4.05. Well, that's outside of the domain. It gives it an error, so it just stops. It doesn't actually connect those pieces. And so that's just one of the ways where just the technology and the programming doesn't tell exactly what it's supposed to do. When I see this, I know that it's supposed to be connected. That comes from experience and stuff. But it's just something to be aware of. Now we have some types of functions. We have even and odd functions. Now, even and odd functions is not the same as even degree and odd degree. Although some even degree functions are even, some odd degree functions are odd. It's a little bit different. An even degree function is, so if the function is f of x that we're working with, an even degree, f of negative x equals f of x. So it doesn't matter if you go positive or negative, you're going to get the same thing. So like y equals x squared is an even degree function. So is cosine of x is even. What this is a horizontal reflection about the y-axis. Specifically about the y-axis, not just any horizontal symmetry. It has to be symmetric about the y-axis. And so that's even. A good way of remembering it, y equals x squared, is symmetric about the y-axis. It's even. Odd, f of negative x equals negative f of x. If you go positive, you go up. If you go negative, you go down, or vice versa. This gives 180 degree rotational symmetry. So if you took your graph and you turned it upside down, it would look the same. And y equals x cubed has, there's an odd function. These are odd. So cosine was an even function. Sine is an odd function because when we graph it, looks kind of like that, where if you turn your phone upside down, if you're watching this on your phone, you turn it upside down, what's going to happen is your screen's going to flip right back upside down. You're still going to be looking at it right side up. So that's a failure on the phone's part. But if it didn't, if you had that locked, it would look the same, assuming that I drew it better than I did. Piecewise defined functions. We've seen these a bit. This is where you get things like f of x equals, and then you have a few different things. We might have x, if, or when, or sometimes it's just a space. That word doesn't matter. Let's see, x is less than or equal to -1, x squared if -1 is less than x is less than 3, and 7 if x is greater than or equal to 3. And so this is the type where it's in chunks. You have different pieces to your graph. We're going to be seeing these types of graphs a bit this year in different situations. But again, it's something that you've seen before. We can graph them. If we wanted to evaluate something for this, like let's say we wanted to know what f of 0 is, we would only plug it into where it would be 0. There, that's when x can equal 0, because 0 is in between -1 and 3. So we'd plug it in, we'd have 0 squared, so f of 0 equals 0. Absolute value functions. Remember, absolute value functions, when we graph them, looks like a V. But if we have f of x equals the absolute value of x, we can actually rewrite this as a piecewise function. F of x equals x when x is greater than or equal to 0, negative x when x is less than 0. Because when it's less than 0, it's negative. So you have negative x. Hey, that makes it positive. That's what an absolute value does. And then finally, composite functions. This is where we have like f of g of x. We use these a lot without even really thinking about it. We use them when we're transforming equations, when we have to replace x with like x plus 3. That's a composite function. And so there's lots of times when using composite functions is easier. An example of a composite function, let's say f of x is 3x minus 7, and g of x equals x squared plus 2, that's a g, f of g of x. We're going to take the f of x function, 3 times something, minus 7, and we're going to plug in the g of x function, x squared plus 2. That's a composite function. So that's a quick overview of functions and their graphs. That was section 2. I'll see you in class. Until then, keep working, keep asking questions, and as always, happy mathing.